Okay guys, in this video we're looking at multiple representations. So we want to be able to visually represent the motion of an object in several different consistent ways that are related to each other. So we know that one of the free response questions on the AP exam is a qualitative-quantitative translation, which means they're going to ask the same question maybe several times and expect a different expression of how you convey that information. So one might be mathematical with numbers, another might be graphs or some kind of diagram. So we want to look at different ways that we'd be expected to represent that motion. And the first way we're going to look at is just a dot diagram. We'll start with constant speed. So imagine an object that's traveling at constant speed. It's able to cover the same distance in equal time intervals. So you have a car that's traveling forward. Every 1 second, it travels the same distance. So if we just kept taking a snapshot of the position of that object, the position would be over equal distances over equal time intervals because it's traveling at a constant speed. And just to simplify, I'll represent the position of that object as just a dot. So that is our dot diagram or motion diagram for constant speed. The other thing I want to add here is if you're not looking at the GIF above, it's not clear what direction the object is traveling. So we can take care of that direction by either drawing an arrow to say that this is the direction of motion, or what I like to do is choose the first position and call that the t equals 0 seconds. So that's when it started, and now it's clear that it's moving to the right at a constant speed. Okay? Again, constant speed is going to be equal distances over equal time intervals. Okay? But what's going to happen when the object changes velocity, if it speeds up or slows down? So if it is speeding up, we could expect that the object is able to cover a larger distance over an equal time interval. So it might start out traveling only a short distance in the first second, but as it speeds up, it's traveling greater distances each second. So my position of the object is going to keep getting spaced out a little bit. And again, I'll represent the direction that it's traveling by saying this is where it started. At t equals 0, it had not traveled a very large distance to get 1 second, but then later on, it's traveling much faster because in 1 second, it's able to go a much larger distance. Okay, so we see the distance between dots is increasing. And the last one, if it were slowing down, then we would expect the dots to start getting closer together. So in the first second, it travels a really great distance, and then later on, it's traveling a much shorter distance. And to show the direction that it's traveling, I'm going to mark my t equals 0 seconds. So that's where it started. Okay, so for slowing down, we should see the dots getting closer together. Hopefully that makes sense. I've done all of mine to the right. So just to recap, we have constant speed moving to the right. We have speeding up, moving to the right. The dots are getting further away. And then slowing down, the dots are getting closer together. Would you like to try at home to do going to the left? Okay, so try constant speed, increasing speed, and decreasing with your t equals 0 over here. Okay, so for our object at constant speed, our dots should be remaining equidistant apart. The increasing speed, we're showing that they're getting further apart, and for decreasing speed, they're getting closer together. Great, so that's again why it's so important to show where the t equals 0 is. If you just look at the dots, this middle one might look like an object moving to the right, but slowing down, right? So it's important that we know, is this going to the left or going to the right? Okay, a vector diagram is just basically a motion diagram with an extra component. We have our dots representing the position of the object, but we're also going to include an arrow for the vector at each, or sorry, an arrow for the velocity at each position. So we can draw that arrow to represent our velocity. The direction of the arrow would be the direction of travel. And also remember that the magnitude of the velocity is represented by how large we draw the arrow. So for an object that's moving faster, we're going to draw the arrows a little bit bigger. So you can see here there's a bigger gap in between. We got that from our motion diagram, and then these velocity arrows are larger in the first case than the second case. So we can convey a lot of information with these simple diagrams. Okay? If it's going at a constant speed, then we're going to keep our velocity vectors at a constant length. If it's speeding up or slowing down, then we're going to see those change, just like we saw the distance between our positions change on the motion diagram. Okay, so moving at constant speed would just be a bunch of velocity vectors that are the same size. If we're speeding up, those velocity vectors are going to keep getting bigger, and if we're slowing down, then the velocity vectors are going to get smaller. Okay, so maybe you want to try that, but traveling to the left. So our t equals 0 is on the right. If it's traveling at a constant speed, go ahead and try that at home. Okay, so constant speed, we're going to show the distance between them is not changing, and the size of the velocity vectors are the same. With the speed increasing, they're getting bigger, but again, we're pointing to the left because this object's traveling in the negative direction. And for decreasing speed, we should show them getting closer together, and the arrows are getting much smaller as well. Okay, so when we do any of these representations, my recommendation to you is do the word description first. Try to describe the motion in words. Once you're confident in your description, then that's going to drive your understanding of the rest of the diagrams, the rest of the graphs. So we really want to make sure that word description is on point, and then the motion diagrams, the vector diagrams are going to be a lot easier once you have that word description under control. Okay, so the next thing that we'll do after this is graphs of position, velocity, and acceleration. Thanks for watching.